Hi everyone, in this video we are going to discuss polyatomic ions. So polyatomic ions can be either cations or anions, so positive or negative, they don't have to be one or the other. But polyatomic just means there's more than one atom or a group of atoms. And these atoms are so frequently found together in nature that we've given them their own unique name instead of following the traditional nomenclature rules. So the first thing we need to do is come up with a definition. So polyatomic, meaning multi-atom, ions are simply groups of ions, and it's always a group, it can't be singular, it has to have more than one ion, groups of ions that have an overall positive or negative charge. And these are still considered anions or cations, just depending on whether or not the charge is positive or negative, okay? But as a whole, we call them polyatomic ions. So now, I have a huge list of things that you just need to put on flashcards and memorize, that you just have to know. There's no other way around it. So here's your name, and here's your formula. So I'm going to start off with one called hydroxide. I'm going to try to write neat. Hydroxide, which is an OH minus. And so this one we're going to see in the near future because an OH minus always indicates that we have a base, okay, an acid-base terminology. But don't worry about that yet. I just want to give you a little hint of where we're going. So anytime you see the ions, OH minus, and it's together, that polyatomic ion, you're going to call it a hydroxide from here on out, okay? Now the next one would be a carbonate. Carbonate is CO3, 2 minus. Okay. The next one is nitrate, ATE. Nitrate is NO3 minus. Now the next one's fairly similar to it. It's nitrite, and nitrite's very similar. It's just NO2 minus. Okay, they each have a -1 charge. Nitrate, ATE, has 3 oxygens. Nitrite has 2 oxygens. Then we have my favorite one, which is phosphate. I really don't know why it's my favorite, but it just is. PO4, 3 minus. I've loved this ever since I was a sophomore in high school. Big nerd. Anyway, sulfate, ATE, is going to be your SO4, 2 minus. And then we also have sulfite, ITE, and very, very similar to sulfate, except for this one we have SO3, but still 2 minus. Okay, the overall charge doesn't change. The 8 and ite is just giving you an indication of how many oxygens there are in that polyatomic ion. All right, so that's all I have for your anions, and then we have 2 cations that you have to memorize. The first one is ammonium. Ammonium, there's 2 M's there, ammonium, and that is NH4 plus. Okay, NH4 plus. And then we have hydronium. Hydronium, which is our H3O plus. And so this is our one that's going to indicate that we have an acid. And sometimes in shorthand you'll just see H plus, but don't worry about that. Yeah, we'll talk about that in the future. So here's your list of polyatomic ions that you have to know. You just have to memorize these. Hydroxide, carbonate, nitrate, nitrite, phosphate, sulfate, sulfite, ammonium, and hydronium. Okay, so you have to memorize those. It's nice if you could get the base and acid part down as well, but don't get hung up on that yet. You will in the future. Now, in terms of nomenclature, they use the same nomenclature as in terms of ionic rules. So same ionic nomenclature rules. But there is one exception, okay? And this is a big exception. So, except, do not change the ending of the polyatomic anions. Okay, so before, if you recall, if we had something like sodium chloride, it would be NaCl. We would change the ending of chlorine to chloride, right? But now if we said Na, and I'm just going to use the one I can see here, SO3, so it would look like this. This is going to be sodium sulfite. You're just going to name it. You don't change it to IDE, sulfide, because that would tell you that you actually have a sulfur, so it completely changes the structure or the actual chemical formula. So what we do with polyatomic ions is you literally just say the word. So it's sodium sulfite. Really easy, really easy. So we're going to go through 3 questions here to see if you can get this. The first one is an exam question. What is the chemical formula? So we're going to work all the way through this from the beginning. Chemical formula for the ionic compound formed from carbonate and potassium. Go. All right, did you get an answer? Hopefully you did. All you have to do is identify cation and anion. So if we're putting these together, your cation is going to go first, your anion goes next, and then you trade your charges. So the plus we know doesn't mean anything because we don't ever write ones, and then the 2 minus we need to write down here. So our chemical formula for this species is K2CO3. Now notice that I said this species. What is the name? That's your next question. How would you name this? Go. All right, did you get an answer? Hopefully you did. The first thing you do is you name your cation. So for this one, it's potassium. The second thing you do is you name your anion. If your anion is a polyatomic ion, you just name it. So CO3 2- is definitely carbonate. The answer to this question is potassium carbonate. Very straightforward. Next one, we're going to give you one more example here. Mg3PO42. What is its name? Go. Did you get an answer? Hopefully you did, but if you didn't, that's okay. The first thing you do is you write out your cation. So your cation is magnesium. And then your anion is a polyatomic ion. So if it's a polyatomic ion, you do not change the ending. You just write out the name of the polyatomic ion. And in this example, that is the phosphate polyatomic anion. So the answer to the question is magnesium phosphate. That's it. Take care of yourself. Have a great week.